All right, Unit 9, Day 2, area of regular polygons and circles. Your essential question, how do you find the area of a regular polygon or a circle? Remember that area is the amount of space taken up on the inside. It's the number of congruent squares inside of those boundaries that we talked about last class. Okay, so we're looking for how many of those congruent squares are there. That is the area, the amount of space on the inside. Also remember that a regular polygon is a polygon that is both equilateral and equiangular. Equilateral, equiangular. So all the sides are congruent, all the angles are congruent. And that's the formula that we're going to talk about right now. So a regular polygon. Here we have a regular 1, 2, 3, 4, 5. Regular heptagon. Okay? So we have 7 sides. Now, what we need to know is we need to know first what this is right here. If you notice, it's kind of like it's this distance right here that forms a 90-degree angle from the center of the figure to one of the sides, any of the sides really. It's going to be the same. It kind of acts like the radius of a circle. But what this is called the apothem. Apothem. So the apothem is what that little A stands for. It's the distance from the center to the side of the polygon. Apothem. So what we need to do in order to find the area of a regular polygon is we need to know the apothem, and we need to know P, which is perimeter. Well, remember that if it's a regular, in this case heptagon, so a regular polygon, okay, all we need to know is we need to know that whatever the side length is, which is S. So we have side length. We know the side length and the number of sides because we know all of these are going to be S. So let's say they're all 2. Well, if this is 2, 2, 2, 2 all the way around, we've got 7 of those times 2. So our perimeter would be 14. So we've got the 1/2, the apothem, times the perimeter. Or we can look at it this way. If you look down here, I've got the other equation. So both of these equations you need to write down. Area equals 1/2 apothem times perimeter. Or you need to, you need to write down area equals 1/2. This is the apothem, the side length, and the number of sides. So we've got the apothem, the side length, and the number of sides, which remember, the SN is really just P, because that's our perimeter all the way around. So if you remember either of those two formulas, it's going to help you with what you're going to do when you're trying to find the area of a regular polygon. Let's do a couple of examples. So we have a regular pentagon in this case. So we know we have 5 sides. So we know that all the sides are 10. Okay? So let's just we'll use the 1/2 apothem times perimeter. Doesn't matter which one you use. All right, so let's fill in what we know. We know the apothem is 8, and we know the perimeter is, well, we've got 10, 10, 10, 10, 10, so that would be 50. So it's 1/2, 8 times 50. So area equals 1/2 of 400. So our area is 200. And again, since it's area, let's say this is 8 feet this time. So that would be 200 feet squared. Would be our area of that regular pentagon. All right, moving to the next one, we have a heptagon. All right, so we're going to use, this time let's use the other formula, 1/2, the apothem, times the side length, times the number of sides. So we have the apothem, the area equals 1/2, the apothem, which is 11, times the side length, which is 6, times the number of sides, which is 7. So let's take 0.5 times 11 times 6 times 7. And I got 231. Let me check that again. Yep, looks good. So let's say those are in inches. So that would mean that would be the area would be 231 inches squared. So again, all you're doing to find area is you're plugging into the formula given and then solving. All right, that's our regular polygons. Now let's change gears a little bit and go to circles. Now you guys probably have dealt with circles before. We're going to start off with circumference because a lot of times people, just like they get perimeter and area mixed up, they get circumference and area mixed up. Well, remember that circumference is the distance around the circle or the perimeter of the circle. Okay? So we have two formulas for that. Circumference equals 2 times pi times r, which is the radius, or the circumference equals the circumference equals pi times the diameter. Now the diameter, remember, is the distance all the way across. So right here is an example of the diameter. And the radius is halfway across. So that's why it's 2 times the radius, because that's really what d is. It's 2 times the radius. Okay, notice I have these things down here. Exact answers, approximate answers. Exact answer, approximate answer. Okay, we're going to do both. When we're talking about the exact answer, and we talked about this a little bit last semester, that's when we keep that equal sign. And the equal sign means we do not plug pi into the calculator. All right? The approximate answer, remember, is the little squiggly equal sign, and that's where we're going to plug in pi, or we're going to use 3.14 for pi, so that way everybody gets the same answer. So make sure if we're plugging in pi, we're using 3.14. Don't use the pi button. Okay? All right. So if I want to find the circumference of this circle, and I want to do the exact answer, I'm going to use, because we know the radius, I'm going to use 2 pi r. So I fill in what I know. So I plug in that 5. We'll go ahead and multiply 2 times 5. So that would be 10. And then what we're going to do is we're going to leave pi. That is our exact answer. And they also say this, you'll see this later on, leave in terms of pi. You'll see that in the directions on your homework tonight or tomorrow. Leave it in terms of pi. All right, the approximate answer, that's where we plug in pi. We use 3.14. So our circumference is still 2 pi r. We still plug in the same thing, plug in 5. Only this time we're going to actually plug in, and we're going to change that to approximately, because when we have approximately, we're going to use 3.14 because we round it. Because remember, pi is a number that goes on forever and ever and ever and ever. So plug that into the calculator. So I've got, let's see, 2 times 3.14 times 5. So I got, I don't know if you can see that very well, but I got 31.4. 31.4. I'm going to leave the little approximately sign, put 31.4. Now, remember that it's perimeter, so if this was 5 feet, this would be 10 pi feet. This would be approximately 31.4 feet. It's the distance around, so it's one dimension, so our units are not squared. Only when it's areas, it's squared. Okay, let's try the other one with the diameter this time. So we're going to use the different formula. All right, so plug in, what's the diameter of this one? 13. If we want to leave it in the exact answer, we just leave it 13 pi. Always put that number in front of pi. Don't put pi in front. So 13 pi would be our answer. Let's say this is centimeters, so we're going to write 13 pi centimeters. That's our equal sign because it is the exact answer. For the approximate answer, we're going to do the same thing. Plug in 13. This time, we're going to change that to approximately, and we're going to take 13 times 3.14. So what is 13 times 3.14? I got 40.82. 40.82. And again, it's centimeters, so we're going to leave it centimeters. Area of the circle. Okay, so make sure you write down this formula for area of a circle. Area equals pi r squared. Pi r squared. Again, we're going to talk about exact answers and approximate answers. Again, we're going to use pi is equal to 3.14, or approximately 3.14. That's what we're going to plug into the calculator when we find the approximate answer. You'll know which one they want you to use, because when they want you to find the exact answer, they're going to have an equal sign. When they want you to find the approximate answer, they're going to have that approximately sign. Okay, so let's plug in what we know here. Okay, we know we're going to use pi r squared. So we're going to plug in pi times r, which is 7 squared. Well, now we've got to do 7 squared. What is 7 squared? 7 squared is 49. We keep that pi. Let's say it's meters, so that would be meters squared. Again, it's area, so we have to have that meter squared, whatever our unit is squared. Okay, same formula, A equals pi r squared. Plug in the same way when we're trying to find the approximate answer, but as soon as we put that pi down as 3.14, we change that to an approximately sign. So we've got 49 times 3.14, and that gives us, I got 153.86. Again, it's meters, so it'll be meters squared. These two answers right here should be very close to the amount, because all we did was the difference between leaving it here. If I went and plugged in the pi button, we get a different number possibly than this right here, because it's going to take it all the way out to pi to the however many places it goes. This, it just took it out, we had it just to the 2 places there. But those are very similar in the amount. Okay, so let's try the other one. This time, notice they give us the diameter, not the radius. So what is the diameter of 16? So remember that the radius is half of that. So it is 8 centimeters is our radius. So A equals pi r squared. We plug in 8. So that would be 64 pi. They told us it was centimeters, so centimeters squared. Our approximate answer, again, pi r squared. Plug in, same exact way. This time, again, it's going to be 64. Once we change that to 3.14, that becomes an approximately sign. So we have 64 times 3.14. I got 200.96, and that would be centimeters squared. Easy as that. All right. A little tougher this time. We know we want to find the area, but we know the circumference. Okay? Well, if I want to find the area, I know I'm going to have to use the formula pi r squared, the area of a circle. What do I need in order to find the area? Well, I need the radius. If I know the circumference, can I find the radius? Well, yeah, because we know that circumference is equal to 2 pi r. So what I'm going to do is plug in what I know. Focus here first. So I plug in 24 pi. That equals 2 pi r. What I'm trying to solve for is this r. Since I want r by itself, I'm going to divide by 2 pi. Well, notice what happens to the pi's. Pi divided by pi cancels out. 24 divided by 2 is 12. So my radius is 12. Now that I know my radius is 12, now I can find the area because I've got my r. I plug it in over here. Okay. It didn't say whether or not to leave it in terms of pi or not, or to keep it exact or approximate. So I don't care. So I'm just going to leave it exact and put 144 pi. If you wanted to go ahead and do it approximately, I would accept that. And we would need to take 144 times 3.14, which would give us approximately 452.16. I don't have the unit here, so what I'm going to do is I'm just going to write units squared. I'm not sure what that is, so I'm just going to write units squared. Okay, now we need to find the circumference where we know the area. So now we need to use the circumference formula, okay, which we know area has radius, so we're going to use the 2 pi r formula there for circumference. We know our area, so let's use the area formula. We need to get the radius in order to get the circumference. So we plug in 9x squared pi equals pi r squared. Well, we're trying to solve for r. So the first thing that we need to do is we need to get rid of that pi. So I divide by pi. Notice what happens, they cancel out. So I'm going to have 9x squared left equals r squared. Okay, so remember back in algebra when you had something squared, how do we undo a square? Well, remember, to undo a square, we have to take the square root. When we take the square root of r squared, we're left with r equals, now we're going to take the square root of everything. The square root of 9 is 3. The square root of x squared, well, what times what is x squared? That's x. So our radius equals 3 times x. Kind of funky, but that's okay. We deal with variables all the time. So we're going to take that 3x now and plug it in. So it's c equals 2 pi times 3x. So c equals 2 times 3 is 6. We have that x and pi. Kind of weird. This is why we don't use the x as a multiplication symbol anymore, because that would totally look like it's 6 times pi, but it's 6x pi. Okay? So I would accept that as our exact answer, or if you want to go ahead and work it out to where we get an approximate answer, I keep forgetting to put approximate there, you would take 6 times 3.14, which is 18.84, and then we'd leave that x there. We can't do anything with that. So either one of those works. Our units are not squared, so it'd just be units and units, not squared because it's circumference. Remember, you're just starting with whatever formula that you need, plug in and solve for the letter that, or the variable that you need to solve for. On your assignment, you're going to have some that are kind of different, where you have to find, it's kind of like what we did on the last assignment where you had to find the answers, you had to find the area of the shaded region. So make sure that you're reading the directions carefully and make sure you're really thinking about what they're asking you to do. Okay, so now we're ready for our summary and our question at the end. Remember, fill in the summary at the bottom of your Cornell notes. That's summarizing what you learned today. And also, please make sure that you write a question. The question is about what we learned, and it can be something that you still don't understand, an example that you need more help on, one of the examples that we did, or a problem that's like the examples that I gave you, so that way we can do a little more practice in case somebody else needs some help. All right, that concludes our lesson on the area of circles and regular